Hello everyone, welcome to the notes for H3-4. Today we're going to focus on nth roots, and we're going to break this lesson into 2 days. So the first one today will focus a little bit more on just square roots, and then tomorrow's lesson we'll get into some higher power roots. Let's begin. So the first part here is just asking us to simplify. I'm going to go over how to simplify square roots again because I feel like there's still a lot of people who are struggling either because you don't remember from Algebra 1 or you didn't pay attention to the review that we already did. This will be our last time reviewing this, so you need to make sure that you're using this opportunity to make sure you fill in these gaps. Okay, there's a couple ways to do it. First of all, when we're taking the square root of something, we're looking for our perfect square factors. If you don't know your perfect squares, you may want to memorize them. If you can't memorize them, then just think about doing this. If I take each of my digits here, like let's say 1 to 10, and I square each of them, it's going to give me all of my perfect squares from, 1 to 100. So if you need to do this, you can do this. I think you probably know a lot of them just already and you don't even realize it, but if I take 1 squared, I get 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. And you can continue on all the way over here, right? And there's plenty more beyond that, but we just don't have the ability to write them all down right now or the time to do it. Okay, normally I have all of my students memorize from 1 to 25 squared. Okay, that way we know a lot more perfect squares that we can deal with in our classes. Okay, due to COVID, we didn't do that yet this year, but that doesn't mean you can't still do that. So if I'm looking to simplify the square root of 24, we know that 24 has a perfect square factor of 4. So with this one, it's pretty easy. We can take it here and take the square root of 24 and make it the square root of 4 times 6. Notice I didn't try to simplify anything. I just changed 24 to 4 times 6. Now, anytime we have a radical and we're multiplying something underneath, we can take that product and break it apart into factors. We can treat this as the square root of 4 times the square root of 6. Okay, it gives us the same values. And the reason we would do that is because 4 is a perfect square, I can take the square root and get 2. 6 doesn't have any perfect square factors, so we're going to leave it as it is, and I get 2 times the square root of 6 as my simplified answer. Okay, now if I wanted to check it, I can just pull out a calculator, and you'll see at the top here, I have done the square root of 24 is equal to about 4.8989, yada, yada, yada. And then 2 times the square root of 6 also gives us the same value. The only thing you have to be careful of is it may not be completely simplified all the time, but we do know that we're on the right track, that we have the right values. Now the second problem, we have the square root of 9/25. Now the same way that we took this product and we broke it into 2 factors, we can take this quotient here and break it into 2 terms as well. We can say this is the same thing as the square root of 9 divided by the square root of 25. So the square root of 9 we know is going to be 3. And I think we know the square root of 25 is 5. So this actually ends up equaling 3/5. Okay, those are both perfect squares. Now as we get into the third one, okay, 54. Maybe you do struggle with remembering your perfect squares and you're not sure what to do with this one. Okay, let me show you a second method for doing this. This one just involves a factor tree. Let's take 54 and let's just come up with its prime factorization. 54 is even, so I know that 2 goes into it 27 times. Okay, 2 is prime, so I'm going to leave it as it is, but 27 is not. It's not even, so 2 doesn't go into it, so I'm going to try 3. 3 goes into it 9 times. Okay, so 3 is prime, 9 is not. 9 is a perfect square, but let's say you didn't recognize that and you broke it down even more. Right now you've got the prime factorization, 2 times 3 times 3 times 3. So let's think about the square root of 54 as 2 times 3 times 3 times 3. Okay, well, does that do much for us? Sort of. Remember, if I take any number and I multiply it by itself, it's like squaring it. So if I think about doing this, 2 times 3, and I have this 3 times 3, I can call this 3 squared. Now I have a perfect square under there, because if 9 is a perfect square, think about up here. If 9 is a perfect square, 3 squared is a perfect square as well. And let's just take it here, and because that's a perfect square, let's break it off of here, and let's put it out here. We have the square root of 3 squared. Okay, and then I still have the square root of 2 times 3 left over. Well, the square root of 3 squared is going to be the same thing as the square root of 9, which is just going to be 3. And then our square root of 2/3, well, 2 times 3 is going to end up being just 6, right? There aren't any perfect square factors to take out. So our answer ends up being 3 times the square root of 6. Now, you possibly could have seen that already and said, oh, okay, so 54 is the same thing as saying the square root of 9 times 6, and then broke it apart and got the square root of 9 times the square root of 6, which was 3 radical 6 as well. Okay, so that's how we did it on the first one. But if you don't get it, you can always take it and do this prime factorization. Just use the factor tree to get it. So a few more for you to practice here. I'm going to go through and explain them. If you already know how to do them there and you wrote down your answer, just fast forward through, check your answer, make sure you're good before you move on. For 80, right, I already know what my perfect square factor is of 80, but if you don't, okay, let's say, for instance, here, you thought it was 4, because 4 does go into it. If I took this and broke this apart into 4 times 20, right, that'd be like the square root of 4 times the square root of 20. However, that gives me 2 radical 20. Okay, 2 radical 20 is the same thing as the square root of 80. However, is it totally simplified? Okay, think about your number 20 here. Does it have any more perfect square factors? Right, you can always take it and think about it as 20 is like 2 times 10. 10 is like 2 times 5. And wait, you've got 2 2's here. Therefore, this is like saying 2 times the quantity or the square root of 2 squared times 5. In which case it breaks apart again, right? 2 times the square root of 2 squared times the square root of 5. Square root of 2 squared is going to be 2, right? Because that's like the square root of 4. So I have 2 times the square root of 5, which gives me 4 times the square root of 5. For the next one, we have a negative square root of 120. Remember, we can't take the square root of a negative, but we can have a negative square root. So just remember, as we're going through this, that we're going to have a negative out in front. If I'm trying to break down the square root of 120, I'm trying to think of perfect square factors that go into 120. All right, well, if you're not sure, take it and you can do your prime factorization. We'll do that up here, right? We have 120 breaks into 2 and 60. 60 breaks into 2 and 30. 30 breaks into 2 and 15, and then 15 breaks into 3 and 5. Well, we just have this one single pair in there. So this is going to be like saying the square root of 2 squared times, and then I just take these 3 and multiply them back together. 2 times 3 is 6, times 5 is 30. So we have 2 squared times 30. And then we'll just break it apart. And the square root of 2 squared is like the square root of 4, which is 2. We have negative 2 times the square root of 30. Number 6, we have the square root of 168. And it's a positive or negative square root of 168. So try to come up with values. If you can't come up with values, just try this again. 168 breaks apart into 2 and 84, which means that 2 goes into it again, so we know 4 goes into the whole thing, but that would be 2 and 42. 42 breaks into 2 and 21. 21 breaks into 3 and 7. So look for your pairs. We only have one pair of 2s. So we're going to say positive or negative square root of 2 squared times 2 times 3 times 7, which is going to be 42. And then we can take it and break it apart. The square root of 2 squared times the square root of 42. And the square root of 2 squared is just going to be 2. And then we'll leave the radical 42 on there. Positive or negative, 2 radical 42 would be our answer. If you're not sure, go down in and do second square root 168, enter, and then do your 2 times the square root. What we say it was 42. And you see you have the same value. Now, what about with variables? First one, we have the square root of x squared. Well, thinking about it, we just said that the square root of 2 squared was a perfect square. So isn't the square root of x squared also going to be a perfect square? Okay, so here's the thing. All even exponents are perfect squares. That is really important to remember. Think about it here as if I was to say, let's use an even number that's not on here. Let's say x to the 6th. Well, if x to the 6th comes from x to the 3rd times an x to the 3rd, right? When we multiply two numbers with the same base, we add their exponents. So that'd be like saying x to the power of 3 plus 3, which is x to the 6th. Okay, but when you're multiplying some number times itself, okay, that's like squaring it. So to take the square root of x squared, right, when we took the square root of 2 squared, okay, like we knew that that was going to equal 2. So that means the square root of x squared is going to end up equaling x. Now, we've been doing it a lot here where we've had, when we're solving problems, we'd say that if we took the square root of x squared, we get the absolute value of x. You don't need to worry about that right now as we're working through this chapter. Okay, so don't worry about that part of it as we're trying to solve some of these right now. Just know the square root of x squared is going to end up equaling x. For number 2, we have the square root of x to the 4th. Well, the square root of x to the 4th would be half of that. So we'd say here that this one is going to equal x to the 2nd power. Now, if you took this, right, you could think about this in another light here too. Remember we talked about rational exponents, talking about power over root. This is the same thing as saying x to the 4th power over the 2nd power, right? So 4 divided by 2 is 2, you get x squared. Just another way to think about it. So if we apply that here, the square root of x to the 10th, right, our root power is 2. So if you're writing it as a rational exponent, it's to the 10th power over our 2nd root, which is really going to say x to the 5th power. Okay, same thing as just saying 10 divided by 2. Now let's look at some more. Now we've got a couple variables in here. So we could treat this as the square root of x to the 14th times the square root of y to the 22nd, just like we did with some of the other problems. And when we split those and then take our square roots, this is going to be an x to the 7th times y to the 11th. So x to the 7th, y to the 11th is our answer. Number 5 now, all of a sudden here, what about when we have this negative exponent? I'm sorry, not negative, that's an odd exponent. So we have the square root of x to the 9th, y to the 18th. All right, so we're still taking like that second root here. If we took this and we broke this apart, we're just like saying the square root of x to the 9th times the square root of y to the 18th. We need to take x to the 9th, right, this value right here, And we need to find a way to figure out what its greatest perfect square factor is. So I want you to think about it here for a second. If we said that all even exponents are perfect squares, then x to the 9th could be rewritten as x to the 8th times an x to the 1st. Okay, so we know that when we multiply two numbers with the same base, we add the exponents. So what I want you to do when you see an odd exponent, you're just going to cut one off. Let's rewrite this as the square root of x to the 8th times an x, and then we'll just leave our y under there because it's got an even exponent. So the square root of x to the 8th times x can be rewritten as the square root of x to the 8th times the square root of x, and then we have our square root of y to the 18th. Okay, I know it seems tedious because I'm showing you every step, but I want you to see every step in your notes so that way if you forget, you can go back and see what to do. We have two perfect squares. This is a perfect square and this is a perfect square. So when I take the square root of x to the 8th, I know I get x to the 4th. When I take the square root of y to the 18th, I get y to the 9th. And then we'll just take this square root of x and put it down here in the back. X to the 4th, y to the 9th, times the square root of x. Let's look at 6. It's very similar. The square root of x to the 5th times y to the 17th. Let's split it apart. I have the square root of x to the 5th times the square root of y to the 17th. They're both odd, so we're going to rewrite them as the square root of x to the 4th times x times the square root of y to the 16th times y. And now we can just take it and break them apart. The square root of x to the 4th times the square root of x times the square root of y to the 16th times the square root of y. This is going to give us an x squared. This is going to give us a y to the 8th, right? A lot of people mess up and put y to the 4th there. It's y to the 8th. And then these don't break down. So we're going to say times the square root of x and times the square root of y. The last part, let's just put it all together. Put the things that are outside together. So we have x squared, y to the 8th. And then on the inside of our square root, we're going to put the x and then the y. And that is our answer. Now, if you're not sure if you're right or wrong, you could always take some values and plug them in for x and y in your original statement and plug them in for x and y in your answer statement, and then it should give you the same value. So now we just have some practice ones for you to try to do. You can try them and fast forward through and check to see if you got them right or wrong. If you got them wrong, I would suggest that you make sure you reach out and you ask a question about them if you can't figure it out. First one, square root of 25x to the 4th, both perfect squares. I'm going to break them apart. Square root of 25 is 5. Square root of x to the 4th is x squared. And that's what we get. The next one, the square root of 8x to the 9th. Let's take the square root of 8 times the square root of x to the 9th. 8 breaks into the square root of 4 times 2. X to the 9th should break into the square root of x to the 8th times x. In which case, right, you don't have to show every one of these steps. I'm just doing it to make sure that anybody who's struggling can follow along. We've got two perfect squares. We've got this one and we've got this one that are perfect squares. So square root of 4 is 2. Square root of x to the 8th is x to the 4th. And then we have a square root of x. We'll just take our things that are on the outside, put them together, 2x to the 4th times our square root of 2x. And that is our answer. Number 3, the square root of 48, x to the 28th, y to the 13th, z to the 15th. I would just take it, Take your time, break it apart. Simplify each, and then put it all back together. So here we go. Square root of 48. When you simplified that one there, right, that was like saying the square root of 16 times 3, which gives you the square root of 16 is 4 times the square root of 3. X to the 28th is a perfect square. That would be x to the 14th. Y to the 13th is not, so we'd have to break that into y to the 12th times y, and then take the square root of each of them. Square root of y to the 12th is y to the 6th, and then we'd have just a square root of y left over. And then z to the 15th, same kind of thing. Let's take it and cut off one. Z to the 14th times z. We know the square root of z to the 14th is going to be z to the 7th. And then we have times the square root of z still. All of these pieces that are on the outside, the 4, x to the 14th, y to the 6th, and z to the 7th, can be moved to the front and rewritten as 4, x to the 14th, y to the 6th, z to the 7th. And then we're going to put one radical, and then we'll put whatever's left over inside of there as a product. 3yz. And that is our answer. 4x to the 14th, y to the 6th, z to the 7th, times the square root of 3yz. All right, I believe these are our last three, so if you're still doing it, good job, hang in there. Let's see how you do. For number 4, I have the square root of 6x to the 3rd, y to the 11th. So I'm going to go ahead and break it apart as the square root of 6, the square root of x to the 3rd, and the square root of y to the 11th. 6 does not have any perfect square factors, so it looks like I'm going to have a square root of 6 something in the end. Square root of x to the 3rd would be the square root of x squared times x. And then our y to the 11th would be y to the 10th times y. When we take our square root, this one, our x comes out, and we're left with the square root of x. For this one, our y to the 5th will come out, and then we still have the square root of y left over. And now we'll just patch together everything that is on the outside, so x, y to the 5th. And then everything on the inside will go back in, 6x, y. That is our answer. Number 5, we have the square root of 124, x to the 19th, y to the 2nd. Break it apart, square root of 124 times the square root of x to the 19th times the square root of y squared. 124, when we take the square root, I don't know. I don't remember what goes into it. So remember, I can take it and do my factor tree. That's 2 and 62. 62 breaks into 2 and 31. And 31's prime, so it looks like we have a winner. 2 squared times 31 would be like saying square root of 2 squared times the square root of 31, which is going to be 2 radical 31. Square root of x to the 19th would be the square root of x to the 18th times x. That's going to give us an x to the 9th times the square root of x. And then the last one, the square root of y squared. Remember, we don't need to worry about absolute value with these ones right now, so we'll just say this will be y because it's a perfect square. And we'll take that and we'll bring that down. Last step for this one, let's put together everything that's on the outside. We have 2x to the 9th y times the square root of 31x. And that is our answer. And then the last one here, number 6, says the square root of -9. And at this point right now, we cannot do that. Okay, so that would be undefined right now. We will learn how to do this later in the year, but undefined, or you could say no solution right now, because cannot take the square root of a negative. That's all we got for this section. Hopefully these helped. And if you have questions, you need to ask, because we're only going to get deeper into it here with the next few lessons. Thanks for watching.